Hey, welcome back. We are continuing our discussion of non-covalent bonds. And today we're going to talk about hydrogen bonds. All right, let's remember polar covalent bonds. So let's say, for example, that we have a bond between nitrogen and hydrogen. Okay, nitrogen is attached to something else right over here. It doesn't matter. But we have a nitrogen atom, single covalent bond to a hydrogen atom. All right, and there is a difference in electronegativity between these two. Okay, so hydrogen has an electronegativity of 2.2 and hydrogen about 3.4. And so if we look at the difference between them, it's a relatively big difference. We have a scale that we can kind of use of electronegativity. So if the difference between two atoms is between 0 and about 0.4, some books say 0.5, doesn't really matter. The idea is simply that there's a difference between these two that is small. We have a non-polar covalent bond. Okay, and if the difference is between 0.4 and let's say about 1.7 is our cutoff, we have a polar covalent bond. And anything bigger than this, we're looking at an ionic bond. Okay, so we have these two atoms. This is their difference in electronegativity, and it's going to fall right in here, 0.82. Okay, so this is a polar covalent bond, and what that means is that we're going to have a very slight charge. So the electrons are going to be spending more time right here around nitrogen, okay, which means that nitrogen is going to be just slightly, just partially negatively charged. And hydrogen is going to be just a little bit positively charged. Okay, now these aren't full charges. It's not like ions where you have +1 and -1. This is just a little bit of a positive and a negative. All right, so this is one bond, and let's say next door we actually have an oxygen. And we can say it's attached to a carbon, and there's some other things over here, doesn't really matter. Once again, between carbon and oxygen, we're going to have a difference in electronegativity. Oxygen is definitely going to be higher. So this is a polar bond once again. And I believe oxygen has an electronegativity of about 3.44, carbon about 2.5. And oxygen, it's better at attracting those electrons once again. So we have this partial or slight negative charge. Carbon has a slight positive charge. All right, and as you know, it's just a fundamental property of matter that positive and negative attract. So this partial positive and this partial negative will be attracted to one another. But once again, this isn't strong enough, not even close, to be an ionic bond. It's going to be a much weaker bond. And in fact, it's going to be what we call a hydrogen bond. And we are going to denote that with a dotted line. So anytime we see a dotted line in a molecular structure, we're going to think hydrogen bond. All right, hydrogen bonds are weak individually, okay, but collectively they can be incredibly strong. And they are critically important in forming molecules that are critical for life, okay? So water, for example, we'll talk more about hydrogen bonds in water, but also DNA. So DNA is a double helix. It has two strands. Those strands are held together in the middle with hydrogen bonds. And then, of course, proteins also rely on hydrogen bonds to keep their three-dimensional structure. Okay, so that's hydrogen bonds.